Okay, let's go put all this stuff together and graph a couple of rational functions. You're going to look at your function. First thing you're going to do is go plug it into your calculator and look at the graph. Then you're going to start dissecting it. You're going to look and see if there are any holes, any vertical asymptotes, either the horizontal or the slant asymptote. Find your intercepts, and then plot everything and make sure your graph looks like the graph on the calculator. So number 1. Go graph x plus 1 times x plus 2 over x plus 2 times 2x minus 1 times x plus 3. I'm going to tell you the graph on the calculator is right here. This is an old school calculator, back before the color, and it also graphed the vertical asymptotes. That was bad. You see how much technology has improved? The calculator that I would graph on the Smart View would no longer graph those two lines, vertical lines. But that's an approximate picture that you should see on your calculator. Okay, let's go dissect it by hand. Do you see any common factors? Yes. X plus 2. So if x plus 2 equals 0, x equals negative 2. You agree? There's a hole there. So there is a hole at negative 2 something. How do we do that something? I plug negative 2 back into what I have remaining. So y equals negative 2 plus 1 over 2 times negative 2 is negative 4, minus 1 is negative 5. Negative 2 plus 1, negative 2 plus 3 is 1. So I get negative 1 over negative 5. I have a hole at the point negative 2, comma 1/5. Say it again. Negative 1 over negative 5 is positive. Okay, any vertical asymptotes? When 2x minus 1 equals 0, x equals 1/2. When x plus 3 equals 0, x equals negative 3. There are vertical asymptotes at x equal 1/2 and x equals negative 3. Say it again. We're getting there. Okay, once you cancel common factors, you had x plus 1 over, what would that be, 2x squared plus 6x minus x is plus 5x minus 3. Do you agree? All I did was this over that. And I multiplied out the denominator. Why did I want to do that? See the degree. The degree of the numerator is 1 because it's x to the first power. The degree of the denominator is 2 because I had a 2x squared. The degree of the numerator is smaller than the degree of the denominator. So I have a horizontal asymptote at y equals 0. Do I have any slant asymptotes? No. I have a horizontal. I cannot have a slant. Okay, let's go after some intercepts. The y-intercept is 0 something, yes? How do I find that something? I plug 0 in for x. You can do it on that one or you can do the original. I'm going to plug it into the reduced. 0 plus 1 over 2 times 0 squared plus 5 times 0 minus 3. What do I get? My y-intercept is at 0, negative 1/3. For x-intercepts, I want y to equal 0, correct? It's a color I haven't used. Let's do that one. For my x-intercepts, I let y equal 0. 0 equals, what was my reduced equation? X plus 1 over 2x squared plus 5x minus 3. Do you see if I multiply both sides by the denominator? I get the denominator times 0. So watch. I don't even need to put any of this. I just set the remaining numerator stuff equal to 0. So the x-intercept is negative 1, 0. To find the x-intercepts, set the remaining factors in your reduced equation that are in your numerator equal to 0 and solve for x. Okay, watch this. The common factors gave you wholes. The stuff in the denominator gave you vertical asymptotes. The stuff remaining in the numerator gives you x-intercepts. Go put all that together on your graph. Where was your whole? Negative 2, 1/5. Negative 2, 1/5. Where are your vertical asymptotes? Negative 3 and 1/2. Negative 3 and 1/2. Where's your horizontal asymptote? Y equals 0. What else did you have? Y-intercept is 0, negative 1/3. 0, negative 1/3. And what was your x-intercept? Negative 1, 0. I'm cheating. I'm looking at my graph on my calculator. But could you draw a rough sketch? It looks something like this. And then it has to go up this way. And then over here. And then you feel very satisfied. Go do it again. First thing, you need to go factor it, correct? You get x minus 2 over, what is that, x plus 3 times x minus 2? If I cancel common factors, x minus 2 equals 0. That's going to be a whole. So my remaining reduced equation is 1 over x plus 3. Do you agree? Okay, where is the whole? At x equal 2. What's the y value going to be? Y is going to equal 1 over 2 plus 3. So there's a whole at 2, 1/5. Everything else remaining in the denominator after I cancel common factors, x plus 3 equals 0. That's going to be a vertical asymptote at x equal negative 3. Looking at the degrees, if I choose to look here or here, this one, the degree is 1, degree is 2, regardless of the one I use, the degree of the numerator is less than the degree of the denominator, so there is a horizontal asymptote where?
0.
Y equals 0. Intercepts. Is there going to be an X intercept?
No.
No. So X intercept is none. For my Y intercept, if I plug 0 into X, I get 1 over 0 plus 3 is 1/3. My y-intercept is 0, 1/3. Is that all we're supposed to find?
That's everything.
Okay, vertical asymptote, x equals 3. No, negative 3 is here. A hole was at 2, 1/5. Y-intercept was at 0, 1/3. Horizontal asymptote at y equals 0. If I look at the graph on my calculator, I can make a quick sketch that looks like that.